Okay, so we will start at 8:05. Okay, we will wait for a few more people to join, and then we will start at 8:05. Is this clear? Okay.
Yeah.
Okay, so let's start then. Okay, just wait a moment. Okay. Am I audible?
Yeah.
Yes, sir.
Okay, fine. Yeah. So let's start. Okay. Okay. Is there any background noise available? I mean, audible from my end?
No,
No.
sir.
Okay, fine. Okay, so let's start. Okay. So let's see. So, okay. So these are our end terms question. So sorry for that. Yeah. So let's start. So see, you have been given a real valued multivariable function. Just wait 1 second. I have to just wait 1 second. Okay. Yeah. So back to the question. So we have been given a multivariable function, which is real valued multivariable function. It is asking you use the Hessian test to answer the given sub questions. So first of all, number of local maxima, number of local minima, number of saddle point. So obviously you would have to find the Hessian matrix. Okay. First you would have to equate the derivative to zero vector in R2, right? Sorry. Yeah, you would have to equate the zero vector in R2. You would have to find the Hessian matrix. Then you would have to evaluate the Hessian matrix at each of these local extrema, which you will be getting from these points. Okay, so you will get all the answers for these three questions. Now, if it is saying if there are no local maxima, that is none of those points which you got as the answer is a local maxima. You have to answer. I mean, enter the answer as 100. Else, okay. So let AB be the local maxima. So they will, ask you to find something. Okay. So whatever this is given. So we will see it at the end. Okay. And similarly for this. So let's start the question. So okay. Anyone any doubt in this? Anyone any doubt?
No, sir.
Yeah. So, okay. So you have been given x cube plus 3xy square minus 3x square minus 3y square plus 5. Okay. So you can see that this is a nice polynomial function. So according to the Carrot's theorem, the mixed partial derivatives, first of all, this will be differentiable everywhere. So the mixed partial derivatives will be same. So you will have a little bit of ease in writing the Hessian matrix. Okay. So yeah, so let's do. So delta f, what is a gradient vector function? It is dou f by dou x, right? Okay, dou f by
Sir,
dou y. Yeah.
how can you make sure it's differentiable everywhere?
See, this is a polynomial function. It will be differentiable everywhere.
Okay. So unless it is piecewise defined, we can say any polynomial function is continuous everywhere.
Yeah, piecewise, or you can see at some point the function may become undefined. Okay, so those places.
Uh-huh.
Yeah. Okay, so
Okay.
3x square. Okay, so let's calculate dou f by dou x. So 3x square plus 3y square, 3x square plus 3y square minus 6x, okay, comma. So dou f by dou y would be 0. Then 6xy 0. Then minus 6y. Okay, so this is your delta f. Now delta f you have to equate to 0 vector. Okay, so what you will get? So 3x square plus 3y square minus 6x is equals to 0, and 6xy minus 6y is equals to 0. So you have got two equations. So what you can do is you can take 6y common from here, and you will get x minus 1 is equals to 0. And here what you can do is, okay, 3x square plus 3y square minus 6x is equals to 0. Okay, so now from here y could be 0 or x could be 1, and this whole thing. Okay, so yeah, so what we can do is, so this is basically p q r. Okay, so you have to solve all these simultaneously. So when you have x is equals to 1, okay, so anyone have any doubt how we solve a system of equations simultaneously? So you have this condition. So P and Q or R. Okay. So you can distribute it P and Q or P and R. Okay. So you will solve these and solve this simultaneously. So you will have two cases. Okay. So yeah. So when x is equals to 1,
Excuse
so
me.
you will yeah.
Pranjal, this is Giri. I just want to know if the recording has started. It's not.
Okay, okay. Okay, okay. Let me check.
Yeah, just
Did
check.
you start the recording?
No, see, when I joined inside, it's starting now. So I just want to know from your side whether it's going
Uh,
on.
yeah, it is showing me call is being recorded.
Okay, okay. Then it's fine. Okay, fine.
Okay.
Thank you.
Yeah, you can leave if you want. No
Yeah,
problem.
yeah, I'll leave.
Okay. Yeah. So see, one more thing, one more tip which you should know. Okay. I mean, some of you might be wondering how did I, what did I write there? Anyone have any doubt? What did I write here?
No, sir.
Everyone knows this.
Yes, son.
Okay. Fine. Yeah.
No,
So
sir.
see this.
Can you explain?
So this is I mean, this is an expression from digital logic. Sorry,
Important
what?
Symbolic logic.
important topics of math too
What important topics of maths too?
for n term.
See, I have already informed that weightage is 50% for your, linear algebra and 50% for your multivariable calculus. So there is no important
Okay.
topic as such. Okay, but the things are obvious. Like that there will be a question for local extrema, maxima, minima, global maxima. Obviously, there will be one multi-part question. Then there will be tangent hyperplane. You know, uh, tangent hyperplane
Multivariable
question.
calculus.
Yeah, multivariable calculus. Yeah, Bhumika, you have some doubt.
So it is not getting live streamed on YouTube.
Okay, it is not getting live stream. Okay, okay. Let me check. I don't know why you all are. Let me check if I can start the streaming from my end. Uh, streaming, manage streaming, start stream with YouTube. Right? Okay. Just hold for 1 or 2 more minutes. I have to ask my code here how to start streaming.
So,
Yeah,
so when will it be uploaded?
yeah, it will be uploaded most probably after midnight. So, okay. The call is being recorded. That is for sure. Okay, so that will definitely get uploaded if even if it is not being live streamed right now. Okay, why?
Okay, so
Okay. Fine. Okay, so 3 plus 3y square minus 6 is equals to 0. So here you will get two values of y square. Am I audible?
Yes,
Yes.
sir, you are audible.
Yes.
Okay. Okay, so what you will get 3y square is equals to 3. Y is equals to plus minus 1. So you have got two values corresponding to x. So you have got 2 points, 1 comma. So okay, we will write it at the end. Okay, so from here, yeah, you have got yeah, for the second case, y is equals to 0. For that, you will find the x value from this expression. So 3x square minus 6x is equals to 0. So you will get, sorry,
This is equal to or 0.
okay, okay, okay. So yeah, just note down all the points. What you have got? 1, 1, okay. Then 1 minus 1. Then from here, 0, comma 0 and 0, comma 2. So these are your four local extremums. Local extremums. We don't
Last
know
one
yet
should be
whether.
2 comma 0.
Oh yeah, sorry. Thanks for correcting. Okay. So 2 comma 0. So these are your local extrema. We don't know yet whether they are
So,
I mean which of them is a yeah.
uh, do we say that they are local extremum or do we say that they are critical points?
Yeah.
Because some
See,
of them can be
obviously,
saddle points also, no, sir?
yeah. See, in all, yeah, saddle point is a local sorry, yeah, saddle point is a critical point which is not a local extremum.
Correct.
Okay, so yeah, you are correct. Yeah, obviously. Okay, so we don't know yet which of these point is what. Okay, So we have to check using Hessian matrix. So first of all, we have to calculate Hessian matrix. So here you know what would it be? Dou square f by dou x square, dou f by dou square f by dou x dou y, right? Then you have dou square f by dou y. Sorry, this is dou x by dou x dou y and dou square f by dou square y. Okay, so this is your Hessian matrix since this is a function in two variables. So yeah, we need to write the Hessian matrix. So let me zoom out a little. Okay. So Hessian matrix would be, so you have dou f by dou x. So this is what this was your dou f by dou x, and this was your dou f by dou y. So you just have to differentiate. So first row you will get by partially differentiating with respect to x. Okay, this vector. Then second row you will get by again by part. Okay, I think this might not be visible, right? My pointer. Okay, so okay, let me write it. 3x square plus 3y square minus 6x. So delta f is 3x square plus 3y square minus 6x comma 6xy minus 6y minus 6y. Okay, so this was your gradient vector function. So let's write hf. So that would be, okay, so differentiate first row you will get by partially differentiating this vector with respect to x. Then second row you will get by differentiating this vector again with respect to y partially. Okay, so just quickly do it. What you will get? So you will get 6x. Okay, 6x minus 6. Okay, not comma. Then you again this vector with respect to x, you will get 6y. Okay, then obviously this will be 6y, but you can check it again. So this will be 6y, and here you will get what you will get. You will get 6x minus 6. Okay. Okay. Is this correct? Can anyone check? So dou f by
Is this
6x
not zero?
minus 6.
Correct, sir.
Is it
What,
six?
0?
Dou square f by dou y square.
Yeah. So see, this is dou f
okay.
by
Yes, sir. Yeah, sorry.
dou y.
Yeah.
Okay. Okay. So now, yeah, you have got your Hessian matrix. What?
I said it's correct.
Okay, 1 1. Then these were your critical points. Okay. So minus 1. Then 0 0. Okay. Then 2
Then
0.
0 2 0.
Okay, so these are your only critical points. Okay, out of these, some might be maxima, some might be minima, or one of them could be a critical point also. Okay,
We have to
so
put them.
yeah, you have to put them here. So HF in this case, HF at 1 1 is put it. What you will get 0, then you will get 6, then you will get 6, then you will get 0. For this HF at 1 comma minus 1 is 0
0
minus 6 minus 6 0. Then HF at 0 0 is minus 6
0
0
mi-
0 and minus 6.
minus 6.
Now HF at 2 0 is 6. Okay, 0 0 6. Clear? So okay, so now you know when you have a function in two variable, a real valued function in two variables, you know the rules, right?
First two are
Plus,
saddle
plus.
points.
I got local max and min.
Yeah. So now you have to find local maxima and minima among these using the Hessian matrices which you have got. So okay. So I will directly do it. Okay, so you remember the signs for three variables, yes or no? What was the sign? Plus plus plus
Plus,
and
plus, plus,
minus plus
minus,
minus,
plus.
right? Okay, if you cut this here, so you will get the case for you know two variables. So plus plus minus plus. So determinant here is negative. Okay, so what is this? Determinant here is negative minus 36. So what would it be? It would
Saddle
be
Saddle point.
saddle point.
Saddle point.
Okay, saddle point. Okay, now what about this? This is
Plus 36.
plus
saddle
36.
No, sir.
Okay,
Minima.
so now you have,
Yes, sir. Minus 36.
yeah.
minus
So what? Sorry.
No, second one is also minus 36, sir.
No, 36. Minus
Yeah.
minus
No, no.
plus.
Yeah, minus 36, right?
No, minus
So
36.
what you will get saddle point.
Saddle point.
Then here you have 36, and here you have first element as negative. So is this the case? This is the case for maximum. Yes or no?
Yes, sir. Maximum.
Okay. So see, this plus tells you the first sub matrix is determinant. So how many sub matrices you can form in a 2 x 2 matrix? First is this matrix. Second is the Hessian matrix itself. So okay, so plus minus is the sign of the first, then plus is the sign of the second, and so on. Okay. So here you will get determinant is 36, and first determinant is plus. So this is, I mean, is positive. So this is minimum. Okay. So you have got your answers. Okay, so how many number of local maxima? One. How many number of local minima? One. How many saddle points? Two. Clear? Okay. Now fourth question. If there are no local maxima, okay, so you can see that there is local maxima. So just jump onto this part. Let AB be the local maxima that is farthest from the origin. If there are more than one such point, then it has the largest x coordinate amongst them. Okay, so let AB be a local maxima so that it is farthest from the origin. So since you have only one local maxima, you can directly find f of AB. Okay, so there is only one local maxima and one local minima. So yeah. So f of AB, what was local maxima? Uh, Local maxima was 0, 0 origin. Okay, so such that it is farthest from the origin. If there are more than such points, then it has the largest x coordinate amongst them. Okay, so f of 0, 0 is
5.
5. And what about this local minima, right? So local minima was minus 2 comma 0.
plus
This was minus 2. Yeah, it was plus 2 comma 0. So what is the answer? So f of AB is f of AB is f of 2 comma 0 is, okay, now you have to find it. So this is 0, this is 0, so
1.
It
8,
is 1, sir. Plus 1.
8, okay, yeah, 8 minus 12 plus 5, so you will get plus 1. So plus 1, okay, and 5. So let's see the answers. Okay, what happened? uh, okay, so all the answers are correct, right? 1 1 2 5 5. Clear?
Sir, a doubt.
Yeah.
Sir, can you quickly explain how did you find the matrix and how did you determine whether it's a saddle point, minimum, and maximum?
Okay, okay. Yeah. So see, you first find the gradient vector, right? So to get the first row, see, this is this. You can write this as dou f by dou x and dou by dou x. Okay, and this second element you can write as dou f by dou y, dou by dou x. So if you see, both these this term is being differentiated with respect to x, and this first order partial derivative is also being differentiated with respect to x. So see, isn't this dou f by dou x, and this is dou f by dou y? So basically, to get the first row, you just have to partially differentiate this vector with respect to x and write the, so differentiate this with respect to x, differentiate this with respect to x partially. You will get these first two terms. That is the first row. Then see, this is dou square f by dou x, dou y. So this is basically to get the second row, you have to partially differentiate this whole vector with respect to y. I mean, not vector, individual terms of it. Okay. So if you do it, you will get 6y and 6x minus 6. So this is how you get your Hessian matrix. Okay. So once you get your Hessian matrix, you have to divide it into sub square matrices. Okay, sub matrices which are square. So first square matrix which you can get from this is sub matrix is this. Then second is this one only. So this first sign is the determinant of first submatrix. Okay, this submatrix SM1. Okay, and this second one is the determinant of this second matrix, submatrix, which you got here, which is your Hessian matrix only, so SM2. Okay, so this helps you to determine, so the sign of these. So determinant of this, so see, determinant of this was here 0, while determinant of this was negative. So there is one more case, less than 0. So in this case, these are saddle points. This is maxima, sorry, minima, and this is maximum. Okay, so I determined that determinant is less than 0. So it is saddle point. Okay, then for this example, you see that first element is negative, that is determinant of first submatrix is negative, and determinant of the second submatrix, or you can say the Hessian matrix itself, is 36, which is positive. So you see the sign, right? Minus plus. So from here, minus plus is maximum and plus plus is minima. Clear? Is this clear?
So, sir,
Yes,
there
sir.
are four
So
possibilities
yes,
for
so I can move to
saddle
next
point.
question.
Kiran, what were you saying?
Sir, for third order partial derivatives, there are four possibilities for a saddle point, right?
Yeah, for three, yeah, for three variable.
Yeah.
So for three variable, it is plus plus plus. Okay, again there will be three sub matrices.
Local minimum.
So plus 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 minus plus minus. So this is maxima. This is minima. Okay, then you have this is maxima. This is minima. Then you have not equal to 0. Okay, not equal to 0, and not in these two entries, not any of the above case. So there you had saddle point, and if it was 0, then what you had was inconclusive case. Okay.
So the first case is local minimum.
Yeah, okay, minima. I am not writing it, I mean, I am trying to write it quickly. Okay, so this is minima, this is maxima. Then when your the determinant of Hessian matrix is not negative, I mean not a 0. Okay, not 0, and it is not any of the above two cases, then you say that it is saddle point. Okay, and if it is 0, then you say that it is inconclusive. Clear?
Yeah.
So again, these are from your lectures, right? Very basic. Uh, okay. Uh,
Sir,
okay. So yeah,
can you please share the PDF on the chat box?
yeah. You will get everything at the end. Okay. Okay. Now this function. Okay. So okay. So this question, fxy is equals to x square minus y square plus 4. Okay. On the disk. Okay. So basically your domain is a circle in R2 of radius 1. Okay. Now choose the correct options. Okay. Choose the correct option. The absolute maxima for f occurs at 2 point, n is equal to 5. Absolute maximum for f occurs at this point. Okay, so on. Okay, so we have to basically go on. I mean, calculating. So delta f would be 2x comma minus 2y. You have to equate it to 0. So you will get 2x as 0 and minus 2y as 0. So x you will get 0, y you will get 0. Okay. So x is equals to 0 and y is equals to 0. So basically you have only 1 point. Yes or no? Yes or no?
Yes.
Okay. So now you have to find the Hessian matrix. So you have to find the Hessian matrix. Okay. So Hessian matrix would be 2 minus, sorry, 2, 0. Differentiate this with respect to x to get the first row, partially differentiated. So 0, then you will get minus 2. Okay, sorry. Yeah, 0. Sorry.
0, yeah.
0, then you will get minus
Minus
2.
2.
So this is your Hessian matrix. Determinant is negative. That is minus 4. So what is it? It is saddle point.
Saddle point.
Now, okay. So absolute maximum of f occurs at 2 points. So now for absolute maximum, you know what you have to do. So first of all, this is wrong. This is correct. So absolute maximum is defined in terms of the function value, what it takes. Okay. So x square minus y square plus 4. So you can check f of x comma y is equals to x square minus y square plus 4 plus 4. So if we try to find the graph of the function, okay, what we can do is
Sir, isn't it plus y square minus 4?
what? Sorry.
Oh, sorry.
What were you saying?
Sir, no, sir. Actually, I don't know what he was asking, but I am just having a doubt, sir. I mean, I don't know if I have missed it, but so this f equal to x square minus y square plus y on the disk S xy
Yeah,
x square plus
yeah.
y square less than 1. What does that mean, sir? Actually, I didn't understand.
So they have restricted the domain. So domain is only this. So if you know that this is x square plus y square is equal to 1 is
It's a
Circle.
circle.
I mean what?
It's a circle, no, sir?
It's a circle.
Yeah, it is the equation of a circle centered at origin. Okay.
And radius less than 1. So that is the boundary of this function, right?
Yeah, so radius less than equal to 1, right? So yeah, so that is the boundary of the function. Okay, so now we have to find function value. So what we can do is absolute minimum for f occurs at only at 0, 1. Absolute minimum for f occurs at 2 points on the boundary of the disk. Okay, we would have to. Okay, so let's do one thing. Let's define some points.
Sir, first, don't we need to find the intersection points between the f and the circle, sir?
F in the circle. So what? No,
Uh,
no.
don't we need to find the intersection points between f and s?
F and S.
No, I don't think so.
No. See,
the-
this is telling you the domain.
Correct, sir. So that means x and y values should be contained within
Yeah. So
this
all those points for which x square plus y square is less than 1. So isn't it a circle?
no, that is circle, sir. But what is the function has its own curve, no? X square minus y square plus y. So let's say it is a I mean, I don't know what is the shape, but let's say it is a parabola kind of thing. Then don't we need to find the intersection points between that and this? Because that is the area that we are concerned about it, no, sir?
Mm.
No, am I making sense?
Corner, yeah.
But there would be infinite such points.
No. Why?
It depends on the function, right?
Yeah. So we need to first understand how x square minus y square plus 4 is, and then we should superimpose that on the circle, and then identify the intersection area, and there we need to see the minimum, maximum, whatever. We have to find the local, I mean, the critical points within that area.
So we already have one critical point 0, 0, right?
See, the thing, it will have only one critical. Okay. So let's see the graph. X square minus y square plus 4.
Hello.
Oh yeah, you can mute yourself, right? Okay, so this is the graph of the function, and it has been restricted to a circle. Okay, so can you see the function?
Yes, sir.
Okay, so let's do one thing. So let's take 0.10 minus 10. Okay, then 0, 1 and 0 comma minus 1, and let's find the values at the function. Okay, so f of 10 would be 5, f of 01 would be
3.
0.
3.
Yeah, so before that minus 0,
Minus 1
minus
0 is
1
also
0,
5.
5. Okay, so then you have a 0, 1 and f of 0 comma minus 1. For that you have 3. Okay, so you have 3 and you have 3. Okay, so what about y is equals to x line? Okay, so y is equals to x line. So suppose
4, sir.
what? Sorry, 4 what?
It is 4.
Y is equal to x.
Y is equal to x.
It's 4.
Y is equals to x. At that point, it would be 1 by square root 2 comma 1 by square root 2, right? Yes or no?
Yes.
Yes, sir, yes.
Okay, so it would be 1 by square root of 2, 1 by square root of 2. So that will give you f of 1 by square root 2, 1 by square root 2 is equals to 1 by 2 minus 1 by 2 plus 4. That will give you 4. Okay, so let's see. Let's try to evaluate what will happen. So, okay.
Sir, why did we find this the function value at 1 by root 2 comma 1 by root 2? I didn't understand that point.
Okay, so what we can do is other thing. Just wait 1 minute. Y square. Okay. Since there are no corners, that is fine. Then what we can do is x square plus y square less than 1. So boundary is x square plus y square. Instead of doing this is the boundary, right? So the possibility of a global maximum occurring is only at boundary now. Okay, so y square is equals to 1 minus x square. Then what we can do is
fxy is f
So f of xy is
f of x.
sorry. Just wait 1 minute. Let me think. We used to do so
X
y
square
square
equal
on
to
this curve. We are doing this. Then we might substitute this point, right? 1 minus x square, that will give you 5. So it would be a constant. Okay, so y is equals to square root of 1 minus x square plus minus, right? So for okay, so for positive half circle we will see, and then for negative half circle we will see. Okay, so y is equals to positive 1, positive value defines this. So let's see. So what you will get, f of x square minus y square. Again, I think you will get the same plus 5. Value will be 5. Okay, so I think everywhere on the boundary, no, it is not the case. Okay, f at x square minus y square plus 5. Okay, x square minus 1 minus x square. So this will give you x square minus of positive square root of 1 minus square root of 1 minus x square plus 5. So this will give you f of 2x square plus 4. Correct? 2x square plus 4. Okay. So now what you can do is, okay, no, that wouldn't work because x is changing also. So you won't be able to differentiate it. Okay.
How you got 2x square?
So I can't
So,
understand how it is.
just wait 1 second. Okay. So I have to think about this. Absolute maximum. See, x square minus y square plus 4 is this. If we start moving, beyond, if we start moving here, this, then it becomes negative. This will start decreasing. So at y is equals to x. Okay. So see, one method which we can use is, okay, if we are not able to do this. Okay, so
Sir, why have you taken plus 5?
what?
X square minus y square plus 5. The function is
X
plus 4.
square, it is, yeah, it is plus 4 only.
Yeah, but you have taken plus 5. X square minus y square plus 4. We have to check the function, this function at the boundary, right? So we just
Yeah,
substitute y is equal to square root of 1 minus x square. But you have taken plus 5,
plus
Just
5 where?
previous, you can you undo? Yeah, isn't it plus 4 x square minus
X
y
square
square?
minus y square plus 4. Okay. So yeah, you are getting
Should be
value
2x
as
square plus 3.
plus 5. Okay, so see, one method which we will see it, we will see this afterwards, but see, one thing which we can, I mean, if you can see the graph. So see, you have this bounded domain. Now if you see y is equals to x line, so this point is square root of 1 by 2 and square root of 1 by 2, right? So if you start moving along this boundary, okay, in this direction, then you can see that my what does, no, it also changes. The thing is, it is changing. So how will we find it? Okay, so f is x square plus x square minus y square plus 4. So when you start moving in this direction, x coordinate is positive, fine. It also changes, it becomes smaller and smaller. while y coordinate becomes larger and larger, and it has a negative in front of it, right? So this whole will be a negative quantity. Okay, so and this is a positive quantity plus 4. So this will be less than 4. Yes or no? Yes or no? It will reach and reach and reach. It will reach here. Here you will have 0, 1. At 0, 1, it is 4. It is 3. Okay. So the value started decreasing from 3. Okay. And it was 5 here. And it was negative of, sorry, 5 here also. You can see at -10 it is 5, and at 10 it is 5. Are you seeing this? Here it is 4. Okay. So this is a symmetrical function. So you have no problem in that. So here it becomes 3, which is the least value. Then what happens? At y is equals to minus x, y is equals to minus x, the value would be 1, I mean the point would be on the boundary would be minus 1 by square root of 2 and plus 1 by square root of 2. Okay, so that would give you 1 by 2 minus 1 by 2 and again 4. Okay, so value starts increasing, reaches 4 here, continues on increasing, reaches 5 here, then again here it is 4 on every point on this line. It starts decreasing, it starts in decreasing till 3, and it starts increasing, moves to 4, and it moves to 5. Can you see this? Hello?
Yes, sir.
Okay,
Yes,
so
sir.
one method is this, but then the thing is, the usual method which we use, where we find the boundary, we substitute the boundary, and we convert the double variable function into a single variable function, and then we differentiate it, right? The thing is here y is also changing with x, so we won't be able to do that. Okay, so if we have found the answers, okay, but I will get back to my instructor and see if there is any other way, like a proper way to see that. But the answer, you can see the absolute maximum for f occurs at 2 points, which is equal to 5. So you can see those 2 points are 1, 0 and -10. Okay,
But if we do your
then
method, also it comes to one variable only, because we are getting 2x squared plus 5. And then if we
yeah,
differentiate it, we'll get 4x and equate it to 0, x equal to 0. And then substitute for y, right? We can probably get the same answer. If we
okay. Let's see this first. Let's answer this. So absolute maximum for f occurs at 2 points, so this is correct. Then absolute maximum for f occurs at only 1 point, this is wrong. Then absolute minimum for f occurs at only 0, 0, 1, this is wrong. So again, this is also true, that is absolute minimum for f occurs at 2 points.
So
Okay,
how
so
you
let's
got
see
maximum 2 points?
absolute.
Maximum 2 points.
So maximum values are 1, 0 and -1, 0. So these 2 points.
Okay, that is by this diagram.
Yeah, yeah. See, one way is to uh, try to see the function. Okay, so let's see what you are saying. So f of x comma y is equals to x square minus y square plus 4 plus 4. Then you had your circle as the boundary or disk. So this is your area for that. Okay. One more thing. I think we answered one thing wrong, which was okay. So yeah, there was one saddle point also, right? So what was the value at the saddle point? It was 4. Okay. Yeah. So minimum, no, everything is correct. So minimum only occurs at 2 points. So okay. So what we were saying was y square is equals to 1 minus x square. This is your boundary. Now y is equals to plus minus square root of 1 minus x square. Okay. Then okay, what we can do is f of x y would become
Square plus
Sir, we
1
can
minus
just
x square. Yeah.
sir, we can just substitute in the function.
Yeah.
2x square plus 3.
2x square plus
2x square
Plus
plus
3. Plus 3.
okay, so this is your f of xy along this boundary.
Correct.
And so similarly, we can do x is equal to plus or minus square root
Yeah,
of
yeah,
1 minus y square,
yeah.
and
So df by d, yeah. So df by dx at on this boundary will give you 6x plus 0. Okay. So what is this giving you?
So we have to
Equate
equate
it to 0.
x
You are
equal
getting
to
x as 0. So this will not give you anything, right?
no, then the corresponding y we have to substitute. So you get
Yeah.
y is
So
equal to 1.
y is equals to 1 you will get. Okay, plus 1. Okay. Then what is the function value? X sorry 0 comma 1 is 0
4 no?
0
4?
minus 1 plus 4. Okay, so you are getting f as 0 1 comma is equals to 3.
3.
3. Okay, so this is the positive part. Okay, this part. But again, it is telling you nothing about you know nothing about the 1 0 point.
At 1 0, f of 0 1 is at 1 0 we have to again substitute x in terms of y.
Okay, see, the thing is, what we can do is, see, this is positive, right? Positive part, and we can divide y in this part. Okay, we can divide the circumference in two parts where y is positive and one where y is negative, and then you will be left with 2 points where y is 0, right? Which is your x-axis.
Yeah.
So for y is equals to minus of square root of 1 minus x square, this will give you x square. Okay, whoever is this, can you please mute yourself? Okay, this will give you again 1 minus x square plus 4. Okay, minus square root of 1 by x square. So this will give you the same thing. So 2x square plus 3. So do df by dx is equals to 6x again
So 0 minus 1. No, sir.
is equals to 0, x is equals to 0, y is equals to minus
1.
minus 1. So you are getting 2 points, 0 comma minus 1. Okay, so f of 0 comma minus 1 would be again 3. Okay, then you are left with 2 points for which y is 0. Okay, y is 0. We divided the boundary in 2 points, I mean 3 parts, two circumferences, not including the points on the x-axis, and you have been left with the x-axis, these 2 points. Okay, so what are these 2 points?
It will be 1 0 and minus
Yeah,
1.
so you can find the points from the function itself. Okay, so no, not function.
What are we finding now here in the circle?
Okay, so this is what?
What are we finding here? Actually,
So we are finding how the function is on the boundaries. Okay.
Okay.
That is boundary for which y is positive and boundary for which y is negative. So this is greater than 0. This is less than 0. Then we are left with two edge cases, which is these 2 points, which are on the x-axis. Okay. So what are those points? This is 1 0
because
and
it's a flat
minus 1
curve.
0.
So if you do a second derivative, it will tell that there is no maxima or minima.
What?
There will be no maxima or minima in this function. It's a circle, and the saddle point is 0.
So see, along the boundary, if you differentiate with respect to x, you are getting some extremum. We don't know whether it is saddle point or anything else, but you can see that if you double differentiate with respect to x, you will get a greater than 0, which is a minima. So that's why we got the 3 value. Okay. Then you have to calculate the function value at these points. So f of 1 0 is 1 minus 0 plus 4,
5.
which is 5, and f of 0 1 is 0 minus 1. Sorry. Minus 1 0.
Minus 1 0. I think it is also same. It is
It is also 5.
Plus 5.
Okay, so we can do it like this also.
So there are
okay. So,
but sir, what we are missing, I think what we will miss is if you substitute this way, it gives us the visibility only along the boundary, but within that boundary, I mean, anywhere within this circle, we don't get to see those things.
Yeah. Okay.
Is that correct, sir?
No. If you see any function's value at any point will be obviously less than what it is at boundary at any point.
Why, sir? Actually, it can go up, down, and anything can happen, no? Between, isn't it?
X square minus y squares. See, the thing is, it is a symmetric graph.
Correct.
So it won't be arbitrary. Okay. And the local extremum we have already found. So if it was inside, see, if it was inside, then you would have been able to define a neighborhood. Okay. If inside, what you are saying is, what about some point which is at inside the boundary?
Yeah, correct.
And it is getting some higher value. So
yeah.
if it was the case, then see, it is not at the boundary, right? It is at the in the inside. So if it was some maxima or minima, right, then it would have been caught by equating this to 0. But we saw that there was no such case because there was only one point when we equated to this to 0. Because for points inside this domain, you would be able to define an open interval, and you would be achieving a maxima, minima, or a saddle point. Then you would have already caught it when you were equating this to 0. Are you getting this now?
Yeah. I think I understand. So when we equate this gradient vector to 0, and if at all we get any points within this circle, then we need to worry about it. Otherwise, we don't need to worry about it because the boundary is limited to this x square plus y square equal to 1, which we already tried along the boundary.
Yeah, exactly. Okay, so any point would have already been caught by equating this. That is, any critical point would have been caught by this. So the only possibility of maxima occurring or minima occurring, that is global maxima, minima occurring, is at the boundary. So that's why we check the both the cases. Okay.
Yeah, so we get two global maximums.
Two global maximums and two global minimums. Okay, so one method was to use this. Okay.
Yes.
But that might not always be possible.
But sir, I didn't understand that method. I mean, you drew the line passing through origin. What is that, sir? I didn't understand.
Okay. See, first of all, I drew the domain. Okay, domain. I knew that this was a circular domain.
Correct.
So, and the function is also symmetric. Okay, it is symmetric. So,
but
I could what?
Okay, sorry, sir. Okay, go ahead. Sorry.
So I could evaluate the function by taking some points and evaluating what is happening. So see, what I did here was, See if you had problem in understanding this. What I did was, first of all, I drew the domain. It was a circle. Then I took some standard points, which was 1, 0, minus 1, 0. Then I took 0, 1. Then I took 0, comma minus 1. Okay. Then, yeah. Then, okay. So I found the values at these points, function value, using the definition. So here it was 5, here it was 5, here it was 3, here it was 3. Okay. Then I took another line, y is equals to x. Okay. So for y is equals to x, this point was actually 1 by square root of 2 and 1 by square root of 2. And I found that at this point and at this point, the function value is 3 and 4 and 4. 4 and 4. Okay, on these 2 points, the function value is 4. Now see here, on these points, okay, when you are moving along the boundary, suppose you are at this point, you are moving along the boundary. So you have two associated ordinates, which is your x ordinate and y ordinate. So when you are at this point, your x ordinate is large, y ordinate is 0. So you start moving your see, if you see the function f is equals to x square minus y square plus 4. Fine. So this is a positive value, this is a positive value, and this is negative. Okay, when you are above this x-axis. So when you move along, you will have a positive value, so this will contribute to a negative value. Okay, so so when you start moving this, your y ordinate becomes bigger and bigger. So you have a positive value. So 5, you have a positive value and you have a negative value. Your negative value becomes bigger and bigger. It starts getting smaller. So your overall value becomes smaller. That's why it becomes 4. Then you move beyond this. Now this y minus y square overpowers x square, because you're, see, add 1 by square root 2 and 1 at this point, 1 by square root 2, 1 by square root 2. Sorry, 1 by square root. Yeah, 1 by square root 2, 1 by square root 2. As you move further, your x ordinate becomes smaller, y ordinate becomes larger. So this x square minus y square, this whole terms become negative. That is y square overpowers this, and you had what, 4. So it becomes less than 4. Getting this? Then add 0, 0, 1, add 0, 1, you get 3. I hope you are getting this.
Yeah, I understand what you were thinking now, sir. Okay.
So I basically got an idea of all the points. See,
yeah, basically you were just checking how could the behavior of the function in between basically this x-axis and y-axis along the circle. For that,
along the boundary.
Along the
so I was
circle.
In a way, I was physically, I was actually checking the function values in a way. Okay,
Correct.
so in a way, I checked all the function value instead of using this derivative.
Correct.
I checked all of them.
Correct.
Okay, since my function was symmetric.
Correct.
Otherwise, it is not possible.
Correct.
So okay, so then it became here 4, it became, then it became 5. So on all these points, it is greater than 3, less than 4. Then it became 5 at here, then less than 5 became 4 at this point, then 3. So I've got entire boundaries idea what is happening there. Okay, so that's why I was able to answer. Okay, so then there was this method. Okay. Okay. So you can see that my function is symmetric also. Okay, that's why it was possible. So let's see another question. Okay, this is choosing the best. Okay, so this is a very similar question, right? This is, I mean, they don't even have given you the domain. Okay, so I will skip this. Do you want me to do this? Hello?
Which question, sir? Which question, sir?
This question, 12th question. It is very similar.
It's a typical polynomial, sir. So I think it should be.
Yeah.
It should be.
What is the maximum product of three non-negative numbers whose sum is 6? So let's try to do this. Okay. What is the maximum product of three non-negative numbers? Sorry, product or product of three non-negative numbers whose sum is 6. Whose sum is 6. So product would be xyz, non-negative. So x is greater than 0, y is greater than 0, z is greater than 0. And you have their sum is x plus y plus 6. Sorry, x plus y plus z is equals to 6. So okay, so this is how you will formulate the question. Is this clear?
Yeah.
Control Shift S. Okay, so I will paste this here. So see, first of all, you should be able to formulate this question. Okay. Okay, so it is asking you what is the maximum product of three non-negative numbers. Okay, so this is important. This term non-negative. So product you just took three numbers x, y, z, and I framed it as a function. Okay, framed the product as a function. So x is greater than 0, y is greater than 0, z is greater than 0, non-negative numbers whose sum is 6. This is another condition. Okay, so
it should be 8, sir.
So
it should be 8, yeah.
Yeah, okay. So see, what is this? This is basically they have restricted the domain in. So this is a plane, if you know. If you can see this is a plane, right? So what would be this plane? This would be. Tell me the points. It would be 6, 0, 0. Okay. Then you would have
0, 6, 0, 6, 0.
0, 6, 0 and
0,
0, 0, 6. Okay. So basically this is a function in 3 variables. Okay. So I can do it with this. Okay, so this three-dimensional region. So basically, this is some sort of pyramid. Okay, so basically like this. Okay, so basically, this is your entire domain, this three-dimensional region, or you can say pyramid. Okay, so now you have to use the same procedure again. So delta F would be YZ, XZ, and XY. Okay, you have to equate it to 0, 0, 0. Okay, what you will get? Y is equals to 0 or Z is equals to 0. Then X is equals to 0 from this, or Z is equals to 0. Okay, X is equals to 0 or Y is equals to 0. Now P Q. Okay, P Q. Then again this is P because these are same. Then R Z is Q. Okay, so you basically have this P or Q. Okay, so I can write it as digital logic also. So P plus Q. Okay, dot R plus Q dot R plus P. Okay. So see, one thing you can directly see it. It is 0, 0, 0, right? Yes, yes or no?
Sir, what is this P plus Q and all that stuff, sir? I didn't understand.
So see, this is one condition. This is one condition. There is an OR here. So P or Q, and so these three conditions are in simultaneous, right? These three are simultaneously to be solved. So plus means or, dot means and okay. So what you can do is you can expand it.
So is that general convention, sir? Plus means or and dot means and, or?
See, the thing is sometimes you might get some bad equations, so you might skip some points. Okay, so this is a good method. I mean, this is a good method to evaluate all the possible conditions. Q, then dot with r plus p. Now you can solve this. Okay, so this is not part, but I am not part of this, but still. So p dot r plus p dot q plus q dot r plus q dot rp. Then okay, I am just solving. Don't worry about this. Okay. Then you will get
So Q,
okay.
What happened to the Q dot Q, sir?
Okay. So the thing is, whenever okay, so for now, just know that whenever you have p p q, you can dissolve this term into just single p. So see, the thing is p and p. Okay, so we don't know whether p holds true or false. Okay, so what should be the value of p dot p? Can it be just p? So see, if it is false, so f false and false will be false, and if p was true, so true and true will be true. So we just write it as p only. Getting this?
Can you repeat, sir?
See, just see, this is just two Boolean variables, right? So suppose there is p and there is, so suppose there is one Boolean variable p. We don't know its value. It could be false or it could be true, right? Yes or no?
Yeah.
It could be false or it could be. Now if I write p and p, p and p. So what you can see, if p was false, so
Then
f
it will be
and
false.
false and false will be false.
Correct.
Okay, and if p was true, so true and true would be true, which
True.
is p itself, right? So whatever was p will give us this.
Oh.
Okay. So see, the thing is, this method actually helps you to find. I mean, consider all the possible cases. Okay, in a simultaneous, when you have lots of conditions, then you can just use this to simplify. So now see, now I've got p p pr qr or qrp. Okay, so basically I have x is equals to 0. Okay, then you have x is equals to 0, and what was r? Y is equals to 0. Then you have what is qr? Can I solve it further? Yeah, I can solve it further. Okay. P plus PRP will give me PR, PRR. Okay. PRR, sorry. PRRP. Okay. P R plus P. Okay, so this was R plus P. So PRR plus PPR plus QR plus QP. Okay, I should have correctly written. This is R plus P. So what I'm getting PR plus PR plus QR plus QP. So PR plus PR would give me PR only plus QR plus QP.
So where did the PQR go?
Where?
PQR?
PQR. Okay, so are you asking this?
Yeah, one more term, PQR.
Okay, so the thing is, see, Q, when you have Q plus PQ, okay, so you can take Q common, 1 plus P. Now 1 is true, and you have OR here. So when 1 is true, and you have OR here, so it becomes 1 only, right?
Okay.
Okay, so I got Q. For these two, I got Q.
Sir, can you repeat that again, sir?
Okay, so see, the thing is, this is not part of this. I mean, yeah.
Okay.
Okay. See, I will write some. So P dot P, when you have a variable P dot P is P, then P plus P is also P. Okay. So these are Boolean laws. You can look it up. Okay. And when you have 1 plus B, this is absorption law. You get 1. And when you have 0 dot anything, you have 0. Okay. See, these are some of the basics. Okay. So how many of you are not getting this?
So it's fine. We can move on.
Yeah, I did not get it fully, sir. I'm able to understand somewhere the concept, but somewhere I'm missing.
Okay. Okay. Fine. So
1 and 0 means true and false, sir. Are you
yeah,
referring
yeah. One
one?
means true.
Okay.
0 means false.
Okay.
Okay. So I will write this clearly. Okay. Okay. So P plus Q. Okay. Dot R plus Q dot R plus P. So you will get. I'm just expanding. Okay. So this is very basic. I mean, you know how to distribute, right? PR plus PQ plus QR plus QQ dot with R plus P. Then you will get PR plus PQ plus so this QQ would become Q only. So QR plus Q R plus P. Okay. So PR plus PQ plus now you can take Q common, so it will become Q1 plus R. Okay. R plus P. So this is nothing but 1 only. So then you will be again you are left with Q here. So you will do the same thing for this. So PR plus P. Okay. P, sorry, PR plus Q. So I will write it. Okay. P plus Q, R plus P. So you will get PR plus Q 1 plus P. So you will get again 1 R plus P. So you will get PR plus Q R plus P. Now you can expand PRR plus PPR plus QR plus QP. Okay. So you will get PR plus PR plus QR plus QP. So these will give you this will give you PR plus QR plus QR. Okay, so this is QP. So you have got PR plus QR plus QP. I think we arrived at the same thing. Okay, so X is 0, Y is 0. So Z would be 0, 0, 0. P Q plus R. Okay, so we can take nothing common out from here. So PR, QR, and QP. So nothing is left to be taken common. So you just write this equation back. So P was Y, Q was Z, R was X. Okay, R was X. P was Y, Q was Z. So Z was P, R was X is equals to 0. Then you have, so now these are all in OR. So what is Q? Q was Y, then r was x equals to 0, then q is y, and p is z. So these are your points. Okay, so the thing is,
Sir,
here
second one.
y value can, yeah.
Second one, QR, no sir. Second one is
Where QR,
this,
right?
yeah, that is
Q
QR.
is,
That QR
yeah.
should translate to Y and Z, no sir. Or
R
Y.
is x. Actually, I took as x. Okay.
Oh.
Y as p and q as z. Okay. Y as p and q as z. Y as p. P and q as z. Yeah. Okay. Sorry. X is equals to 0. Y as p. Q as z. So z is equals to 0. R as x, right? Z is equals to 0. Then you have
Y.
Q. What was Q? Q was z, right? And p was q. So q was z. Z is equals to 0 and p was y. Okay, yeah, correct. Okay. So now, okay, so at all these points, so 0 comma 0 comma z could take any value, then 0 comma 0 comma, sorry, 0 comma y comma 0, x can take any value, and okay, so what you will get, okay, so can you see one thing?
No, third
These
one.
are all these points. Yeah, what?
Third one is
So,
x00, no sir.
Third one is, yeah, x is 0 0. So see, now one thing you should note is that this is your which axis? This is your z axis, this is your y axis, this is your x axis. Now the thing is, if you see the function back, these are all your boundaries, right? Are
Yes.
they?
Yes.
Okay. So the thing is, on all these boundaries, the function value is 0. Okay. Function value is 0 on all these points. So what are we left with then? So the value must be on this surface, not even on the corners. Are you getting this?
Yeah, corners are already 0, sir. Corners are 0.
Yeah, corners are 0. Even on the boundaries, all the values are 0. You can see it from it.
Correct.
Okay. Now what you have to do is, now again, see this was easy, but I was showing you the concept. So see, now what you have to do is, you have to check on the boundary, which is what is left. This face is left, right, of the domain. So what you have to do is, you have to just substitute. So let's do one thing. Let's substitute z. So z is equals to 6 minus minus x minus y. So x comma y comma z. So this is x y z, and x plus y plus z is equals to 6. So z I can do as 6 minus x minus y. So what you will get? You will suppose g. So what you will get? X y 6 minus x minus y. So g function is xy 6xy minus x square y minus xy square. Okay. Now what you can do is, you can find the partial derivative. Okay. So what you will get? Just do the partial differentiation with respect to x, then with respect to y, since this is a function on two variable.
6y.
Sorry.
6y.
So you will get 6y
minus
of 2xy. Okay. Minus of y square, comma. Then you will get with respect to y 6x minus of x square minus of 2xy. Now you have to equate it to 0. So you will get 6y minus 2xy minus y square is equals to 0. then you will get 6x minus x square minus 2xy is equals to 0. So you can take y common from here. Okay, so 6 minus 2x minus of x, so minus of y, right? You are getting 6y. I've written this correctly. 6 minus 2x minus y. Okay, equal to 0. Then you have this. What was it? You have to take x common. Okay, so 6 minus of x minus of 2y is equals to 0. So now see, okay, so now this implies y is equal to 0, or 6 minus 2x minus y is equals to 0. Okay, or x is equals to, and sorry, this is and x is equals to 0, or 6 minus x minus 2y is equals to 0. Now you will see that it is actually quite useful what I was telling you before. Okay, so okay, again just p q, then you have, so see, now you will have different 6 minus x minus 2y, so all these are different. So p q r s. Okay, so see, there's an or, so write or, so there is a plus, and if there is an and here, so dot r plus s. Okay, so p dot r plus p dot s plus q dot r plus q dot s. Now you cannot solve it any further, so you basically have 4 cases. Clear? So if anyone had ever any doubt in how we solve, simultaneous equations, it might be the case that you were lucky till now that uh, you used to get correct answer. So now you know how to form all the cases. Okay, so if it was further simplifying, then you will simplify, and you will reach such a state, okay, which we did earlier. So see, okay, I added a page here. So see, how many cases there were at the end? So there were all these 3 cases only. Okay, so after simplifying, you will get all the cases. You will never miss any case. So now you have case 1, where p dot r, which is y is equals to 0, and r, x is equals to
X
0.
equals 0.
So these for this, what will be z? Z would be 6, right? Z would be 6. Yes or no?
Yeah.
Since z is equals to 6 minus x minus y.
Correct.
Right? So z is equals to 6. Okay, so this is case 1.
Sir,
Then case
actually,
2 is,
sir, the given that x, y, and z are all positive, this case itself is probably not valid, sir.
what? 0, 0?
No, x, y, z are all positive is what was given. So x equal to y, x equal to 0, y equal to 0 is not a valid case, no, sir.
No, it is written non-negative.
Oh, non-negative. Okay. Okay.
Okay, non-negative includes 0.
Okay.
Okay, so p dot s, p is y is equals to 0, and and what is the point?
6 minus x,
Uh,
6 minus x minus
uh,
2.
sorry, s was this 6 minus x minus
2y.
2y is equals to 0. So this will substitute y. You will get x as 6. Now what you will get z as, z is equals to 6 minus x minus y, right? So you will again get 0. So what is one point? So this point was 0, 0, 6. Now you can see this point is at the boundary. So you will, obviously remove this because it is 0. Then you will get a 0, 0, 6, 0, 0. Okay. Then again, this is also on boundary. So q dot r, q dot r. So I think these two only will be the useful cases. So 6 minus 2x minus y is equals to 0, and 6 minus x minus 2y is equals to 0. So let's do this. So multiply this with 2, okay, to equate x's coefficient. So 6 minus 2x minus y is equals to 0. Then you get 12 minus 2x minus 4y is equals to 0. Now subtract second equation from first. So you will get minus 6 then what you will get? Minus 6 and
plus 3y equal to 0.
plus of 3y is equals to 0. So 3y is equals to 6. Y is equals to 2. X is equals to, just calculate it from here. So y x is equals to 2 only. Okay, so from substitute here. So you will get 6 minus 2 into 2. Sorry, 2x minus of y. Y is 2. So is equals to 0. So you will get 4 is equals to 2x. So x is equals to 2. So x is equals to 2. Now z is also 2. Okay. So this is most probably your point, which is your answer. Because for rest of the points, you can see now one more is left, right? QS. So when z is 0, your other variable, one more variable will come to be 0, and that will be a corner point again. So your answer is x is equals to 2. So 2, 2, 2. So what is your product? 8. Is it clear? Is it clear?
Yeah. Okay. Yeah, let's do one more question. Okay, so I hope you got this. Then, okay. Okay, anyone this question? Okay, so we have done enough questions because, okay, I will tell you what you have to do here. So what you will do here is, you will integrate it with respect to x. Okay, so this is a definite integral. So you will get some function in a and b after substituting the limits. So you will get a function in a and b, and after that, all things are same. Is it clear? Is this clear? Is it clear? Yes, sir. I think we have done
Okay.
very similar thing in one of the activity
Yeah,
questions.
yeah. There is one of the activity questions which is very similar to this.
Yeah.
Okay. Then, okay, consider a plane. Let ABC be the point on the plane such that the distance of the point from the origin is the least. Okay. Okay. Use the information to answer the given sub question. So basically, see, ABC is a point which has the least distance. So what you will do is, you will formulate a function which basically okay. Do you want me to do this again? This is a very similar question. It's just that you will use Euclidean distance, okay, as the function. Then you have a given condition. So,
Sir,
yeah.
isn't the answer 32
For what?
for the first one?
For the first one, you mean this question?
3 minus.
This question?
Yeah.
11th question.
No, the previous one. No, the 48 times a plus b.
We haven't done this yet. So, x plus y plus z is equals to 1. Okay. Let a be the point. Yeah, yeah. So I know what you did. Okay. Okay. So that is a good observation. But if you, I mean, some might not be able to do that, right? So see, the thing is, what he did was, he directly applied the formula. See, this can be solved very easily if you know the formula, because some people might not know the direct formula. Okay. Which is modulus. So when you have a plane and you have a point, so the point in question is origin. Okay, origin. So what he did, how he told so fast was, okay, I will tell you. Okay. So see, I will directly tell you the formula. Okay. So the thing is, if you have a point, okay, if you have a point, so suppose this is your point and this is some plane. Okay. So if you want to find the minimum distance of the point from the plane, so okay, instead of origin, suppose it is A, B, and C. Okay. So the direct formula is, so suppose the x plus y plus what you have the plane equation. Okay, so -1 is also 0. So what you have to do is, first you have to write the plane in this form. You have to make the RHS 0. Then the distance formula is directly. So minimum distance of a point from plane is this. Modulus of, you will substitute the point in this plane, then this LHS. So you will get A plus B plus C minus 1. Okay. Modulus of summation of the coefficients in front of the variables in the plane. So you will get 1 square plus 1 square plus 1 square. Okay. So now tell me. Okay. Okay. Remember this formula. Okay. So the coefficient in front of x, y, and z. So 1 square plus 1 square plus 1 square. Okay. So this is your direct distance. Okay. So what you can do is, the point in question is the origin. Okay. So distance would be, so your plane is x plus y plus z, -1 is equals to 0. So mod of, substituted here in the LHS, 0 plus 0 plus 0 minus 1 mod upon square root of 1 square plus 1 square plus 1 square. So you will get 1 by modulus of 3. Yeah, this is the distance. Now you can find the point ABC, whichever it was. Okay. And the first method which I told you was, which I was going to tell you was, you basically can formulate a function. So a comma b comma c, this is the point in question. Okay. What would be its distance? It would be square root of 1 plus, sorry, what is the distance between 2 points? So you have 1 point this,
A square
and
plus
you have
C
a point.
plus C square.
Okay. So it would be x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. So here it all are 0. So a square plus b square plus c square. Okay. Now what, yeah, you can see this is a monotonic function. Okay, it will always keep on increasing. So what you can do is, instead of you need to minimize the point, right? So what you can do is, let's complete this. Yeah, so what I will do is, I will take g, and I will take square of this function. So a square plus b square plus c square. Okay. Okay, and you had the case that x square plus sorry, you had the plane, right? X plus y plus z is equals to 1. Okay, the point lies on the plane, so that is for sure. So what you can do is, just substitute one of the point. So z is equals to, so a plus b plus c. Okay, this point lies on the plane, right? So what you can do is 1 minus a minus b. So you can substitute here. So g is equals to a square plus b square plus 1 minus a minus b whole square. So g of ab is a square plus b square. Now, okay, so you will get 1 minus a minus b. Okay, minus a minus b. So what we can do is 1 minus a minus b, if you don't remember the formula. So minus of a plus of a square plus of ab, then minus of b plus of ab plus of b square. So just simplify this formula now. So what you will get? So there are 2a square plus 2b square. Then you have minus of a minus of a. So you will get minus of 2a, so minus of 2a minus of 2b. Then you have plus of 2ab. Yeah, so we have written everything. Now what you can do is, you can find, you can equate the gradient vector function to 0 0. So this would be differentiated with respect to a, then with respect to y partially, So you will get 4a. Okay, 4a minus 2, 4a minus 2 plus 2b, comma. Then you will have 4b minus 2 plus 2a. Now you have to equate it to 0. So 4a minus 2 plus 2b is equals to 0, and 4b minus 2 plus 2a is equals to 0. So these are just linear equations. You can directly solve them. So 4a plus 2b is equals to 2. Then you have 4b minus 2a. Sorry, 4b plus 2a. So 2a plus 4b is equals to 2. So just solve this. So I will multiply this by 2 and then subtract it. So what will I get? What will I get? Minus of, so 2b minus 8b minus 6b. Then you will get 2 minus 4, which is minus 2. So 6 is equals to 1. B is equals to 1 by 3. Then find a value. A value would be
It will be 1 by 3.
Yeah, a value would be 2 minus 2b upon 4. So you can substitute it here, 2 by 3. 2 minus 2, sorry, 2 minus 2b. 2 minus 2 by 3 by 4. So you will get 4 by 3, 4 by 3 upon 4. Is it 1 by 3?
Yes, it should be 1 by 3, sir. It should be 1 by 3.
1 by 3. Yeah, so you have got your point at which the function is, it is a critical point. So, yeah. Okay. So we are not done yet. What you have to do is, you have to calculate the Hessian matrix also. So 4, then you will have 2. Okay, I am differentiating this with respect to a. So 4, and you will get 2, and here you will get 2, and here you will get 4. So what is the determinant? Determinant is greater than 0. Okay, and first value is positive, and 4 is greater than 0. So it is a minima. Okay, it is a minima. Okay, so you cannot just jump on to conclusion at this point. You are not sure, right? So minima. But the thing is, if you see the function itself, this function is a very common function which you will see. It is a very common convex function, or you can see that it is like this, a parabolic function in R3. Okay, so this is your minima. You are now sure. So just find the value of the function.
Sir, why did you say that we cannot conclude?
What?
No, why did you say that we cannot just conclude based on this Hessian matrix?
No, on Hessian after calculating Hessian matrix, you can conclude, but not at this point when you just calculated the, A and B value.
Oh.
That is the point.
Yeah, okay.
And C was, what was C? C was, we forgot C. C was 1 minus A minus B. So 1 minus 1 by 3 minus 1 by 3.
That should be 1 by 3.
So this will give you 3 minus, okay, 1 by 3. Okay, so 1 by 3. So what is your function value? Okay, so you have got your point. You need not calculate the function value. So 4 1 by 3 plus 1 by 3. This is 48. Sorry, 48 into 2 by 3. So you will get 1 6. So 32. Okay. So this is your answer. Now, if D is the minimum distance, so what was D? So D was square root of 1 by 3, if you remember the formula. So they are asking you 27 D square. So 27 into 1 by 3, which is 9. Clear? Is this clear? Okay. So if you remember the formula, very good. Otherwise, you have got your points, and you can just substitute the value in value. Okay. So again, you will not substitute the value in G. You will substitute the value in F, because G we have squared. So you can substitute in g, then you have to take square root to get to the original, because this is Euclidean distance, right? There is a square root. So what you can do is, so let's see, g is equals to a square plus b square plus c square, which is 1 by 9 plus 1 by 9 plus 1 by 9, which is 3 by 9, so 1 by 3. So what you have to do is, for
Square root.
actual value, you have to square root. So you will get 1 by square root of 3. Okay, so if you don't remember the formula, fine. Just read the question and try to see what they are saying. Okay. The thing is, most of the people will not remember this formula. I mean, will not know this formula if they haven't studied planes in their 11th and 12th standard. So if you remember this, very good. Otherwise, it's fine.
Sir,
Yeah.
sir, we can just take the scalar of the normal vector. And we can compare
Scalar of the
normal vector.
yeah. See, that part is not covered. We see if you know, very good. The thing is, these coefficients is nothing but the normal vector. Okay. But okay, if you know, very good. Others don't know, right? So don't worry. Okay.
Sir,
So
sir has
yeah.
explained that in instructor session.
Okay. In instructor session, they have explained because I think it is not in the lectures, right?
No, not in lectures, but
Okay. So if someone has seen only lectures, then see, I told you the original method of solving this question, right? Which is this: formulating a function, whatever the question says. So you know the distance of a point from some point. You know the distance, so you formulated it. You took some point, and you formulated it. Then you did what was the normal procedure. Okay. So if you don't know, then it is fine. If you know, very good. Okay. Okay. Yeah, your volume is very less. Like,
Can you hear me?
yeah. Okay. My speaker volume is. Oh yeah, go on.
Yeah. So in that, can you show that screen?
Okay.
In that you squared the function, so that will not make any difference.
No, it will not make any difference. Because see, you first have to check. So the thing is, this is a monotonic function. It will always increase, never decrease. See, all these are positive quantities. So if it is a monotonic function, then you can square it. It will have no effect on the minimum maximum. But if it is not a monotonic function, then it would change. So most of the times, the given question involves monotonic function, like volume function, x, y, z. Okay. First of all, there is constraint, like if there is suppose x, y, z are lengths of your sides of a cube. Then you know x is greater than 0, y is greater than 0, z is greater than 0. These are the obvious conditions. So when you increase, so suppose they have given you a domain z square is equals to 1, then you will, instead of doing this z is equals to 1 minus x square minus y square, then substituting the square root term here. So you can do this in this method also, but the thing is, it will be a little difficult because it will involve square roots, right? So what you can do is just do v square is equals to x square y square z square. Now this is you can see it, that this when you increase x, y, z value, it will always be a monotonic function. You know monotonic function, right?
Meaning it's always been this.
Yeah. So if there is a point x1, if there is a point x2,
Okay.
if x2 is greater than x1, then f of x2 will always be greater than x1. Okay. So yeah. So that's why, yeah.
But so x2, if x2 is greater than x1, fx2 is greater than fx1. That's correct.
Yeah.
But
Yeah.
we have a constraint here, no, sir. XYZ product is constrained by x plus y plus z equal to something. So, so how can we say that?
No. It is a constraint on the domain. Okay. So inside that domain, it is showing you the monotonic nature. Okay. It is in the domain. The constraint is on the domain. See, the constraint is on the domain. I hope you are getting
so, No, when we are talking about volume XYZ, XYZ.
See, a constraint will just restrict the domain. It will have no effect on the nature of the function, right? So if it was minima, after squaring it also, it will be minima. It will not change. It's just that that function will just be defined in that domain. I hope you are getting this. Is this constraint changing the nature of this function at all? It is just restricting the points at which function is defined, right? It is not changing the nature of this function. Are you getting this?
No, sir. Actually, see what. Okay, I don't know what I'm missing, but see, what you're saying is if x is increasing, function value increases, is what you're saying.
Yeah.
Which I agree, but when x is increasing, y and z have to decrease, no, sir, because of the constraint. All three are dependent.
You are actually confusing both. Somehow you are relating the function with the constraint. This constraint is just restricting the domain points.
Correct.
Okay. So if there is some domain point, so see, this domain is actually a sphere. If I remember, I think this is a sphere. Okay. Okay, I should give you a simpler example. Okay, just wait at the end. I will explain it. Okay, because you are confusing these two things: the function nature and the domain. Okay. See, function nature is independent of the domain here, right?
I agree.
This is just
function,
restricting
yes.
the
I agree, sir. Standalone function is monotonic. Agree.
Yeah. See, you are saying that if z takes large value, x and y should take less value, right? But
correct.
That is the point. If there is a point for which z is large, these two coordinates will be small, right? Where is the function in this?
No, those two values will take smaller values, and so volume will. You don't know whether volume is increasing or decreasing. Is what my point, sir. Because when you increase z, x and y have to decrease because of the constraint, and thereby the volume need not necessarily increase. Is my point.
Okay, I will explain it at the end because you are
okay, sir, no problem.
Okay, so I think we have seen enough of these types of questions. Okay, Hessian matrix, again, you can do it yourself. Then, okay, let's see some tangent questions. Okay.
So, do we have anything in kernel? What is that? Kernel and
Kernel
image?
part we have already covered in last session, right?
Oh, okay.
So those questions are also included as a part of the syllabus.
Yeah. There is linear algebra 50% and 50% for calculus. Okay. Sorry. These are all your tangent line equations. So let's first do some tangent plane question. Find subspaces represent the tangent line in the direction vector this. Okay, so I hope you are aware with this parametric form of a line in 3 dimension.
Yes, sir.
Okay. Okay. What about rest of you?
It would be nice if you can refresh it.
Okay. Let's do this one. Okay. So tangent line. Okay. One thing you should always keep in mind is tangent line is different from tangent hyperplane. Tangent hyperplane is a plane which contains all the possible tangent lines at a given point in all possible directions. Okay, given the function is differentiable at that point. Tangent line is just a single line. Okay, single line which is tangent to the slice of the function contained in the line which is parallel to the directional vector passing through the point in the origin. Okay, so very easy question. Fine. So your f of xy is equals to x cube plus y cube. Okay, so if you okay, so graph of this function will lie in R3. Yes or no? Yes or no? Okay, so can you tell? Sorry. Okay.
Yes.
Okay, so can you tell me the parametric equation x of t comma y of t comma z of t is equals to, yeah, tell me the, so okay, if you don't remember, so there is a point.
F of
So
AB.
yeah, so that what is the point? It is 1 1. Okay, so point is 1 1. Then what is the direction vector? One more thing, direction vector always needs to be, tell me, direction vector.
Unit norm.
Yeah, it should always be a normalized unit vector. Normalized vector, that is a unit vector. So is this?
No.
1 by root 2, 1
It
by
is
root
not.
2.
So you would have to first normalize it. Otherwise, you will get wrong answer. Okay, so 1 by square root 2, 1 by square root 2. Now the formula is A1. Okay, so A tilde represents A1, A2. Okay. So A1, A2, comma, f of
A1, A2.
plus T, U1, U2, comma,
F,
FU of
FU of A1,
of
A2.
A tilde. Okay. So now we are left with two quantities, which is f of A1, A2 and FU of A tilde. Okay, that is A1. So what is f of A1, A2?
A cube plus B cube.
So 2, right? 2. That is 1 plus 1 cube plus 1 cube.
Yeah.
Now again, this function is a nice polynomial function. So directional directional derivative will obviously exist at the given point. Okay. So see, whenever these questions are asked, I mean, see, if the option involves that directional derivative does not exist, that is tangent line is not possible, then you should be cautious that it could be possible that at that point it is not possible. But when you can see that all four options are giving you some equation, so just don't worry about it, right? That is, it is presumed that it will be existing. Okay, so you have to fu of a1 a2. So what is the formula? It is derivative, gradient vector at a1 a2 dot product with u1 u2. Yes or no?
Yes, sir.
So f of a1 a2 is, so now you have to find, so that would be so okay, let me write. So 3x square 3y square. Okay, so a1 a2 you would be 3 comma 3 dot product with 1 by square root 2 1 by square root 2. So you will get 2 into 3 into 1 by square. Okay, so okay, let me not write that. So 3 by square root 2 plus 3 by square root 2, which is 3 square root 2, right? Okay, so yeah, now you have got all things. So okay, so you will get 3 square root 2. So now you just have to place them in this formula. So what you will get? xt yt zt is equals to 1 comma 1 comma, so a1 is 1, a2 is 1, that is the point in question. F of a1 a2 is, yeah, anyone wants to say anything? 2 plus t times of u1 is what is u1? U1 is 1 by root 2 1 by root 2 and 3 square root 2. So fu is 3 square root, right? So now you can write x as 1 plus t times of 1 by square root 2. So t by square root 2. Y as 1 plus t by square root 2. And z as t plus, 2 plus 3 square root 2 t, right? So now what you have to do is you just have to express each of these variables in terms of t. So x minus 1 square root 2 is equals to t. Y minus 1 square root 2 is equals to t. Z minus 2 by 3 root 2 is equals to t. Now what you have to do is the thing is the coefficient of the variables should always be 1. So what you will do is x minus 1 by 1 by square root of 2 is equals to t. Okay, so you will manipulate it, is equals to again y minus 1 by square root of 2 is equals to z minus 2 by 3 square root of 2 is equals to, okay, so you have got your equation. So just match it.
Oh, sir, it's 1 by root 2. Y minus 1 by 1 by root 2.
Y minus
1 by
yeah, sorry. Okay, so x minus 1 by square root of 2, then you have y minus 1 by square root of 2, and z as z minus 2.
Third option.
Okay, so what they have done, they have so they have rationalized it. Okay, so what you can do is square root of 2 by square, so you will get 6 by square root of 2. So just match it. So is this the answer?
Yes, sir.
Okay, so yeah, nothing much.
Sir?
Yeah.
What's the use of symmetric form?
Symmetric form is just one way of representing a line in 3 dimension. Okay. Similarly, there is parametric form. All forms represent the same line, right? So I don't know whether some function will have some. Okay, yeah. So I think there are some, when we represent a line in parametric form, symmetric form, these I don't remember, but these represent something. Okay.
Yeah, U1, U2, and FU
Yeah,
of
these
A, comma B.
yeah, these represent something. But I'm not sure what it was it, because I studied it quite a long back. Okay,
So those
yeah,
are the coordinates of the direction vector, and the last one would be the directional derivative respectively.
okay. Right. But as of different form, they are not no different, right? You can get anything from any form, so no specific form has any specific use. Okay. The thing is, this will help you to determine some quantities when you express it in this form. Okay. If I remember, there was some angles related to, right? There was some cos alpha, cos beta, cos gamma. So I'm not sure. You can look it up. Okay. Parametric form. Sorry, symmetric form. Okay. So this is the question. Then one more question we will do. Okay. Tangent. Okay. We have done one question from tangent line. Let's see tangent plane. Okay. So let's do this because this involves lots of, yeah. So let's do this one. Okay. I have to zoom it out. Equation of surface, equation of plane. Then you have okay, one more thing you should notice that whenever you have a multivariable function that is real value, it will always be a surface. Okay, the graph of it. Okay.
So what is that? Whenever we have multivariable function,
which is a real value. So you know that it's, see, suppose you have x1, x2, x3, x4, x5. So you have 5 variable function which is real valued. Okay, x2, x3, x4, x5. Okay, Then you know the graph is basically a collection of points. So what is your last coordinate? So you have 5 variables. Your
Function of these 5.
yeah, it would be x5
Function of this.
f of x tilde. Okay, so all these points will be your graph. So they will represent a surface. The thing is, you cannot visualize it in R4, but it will be a surface. Okay. Because we are dealing with such functions which are real value. Okay, should we do this? Okay, let's do this only. Okay, I need to zoom. Match the columns of the surface in column A. Match the equation of the surface in the column A with the tangent plane at 112. Okay, tangent plane equation. Then and the vectors subspace corresponding to the affine subspace formed by the tangent plane. Okay, so this is easy then. Okay, so in tomorrow's session we will, I mean, what will be covered will be limits and partial derivatives. Sorry. Okay, so let's see. Okay, so they
Sir?
have given, yeah.
Do you get questions on continuity also?
Yeah. So in tomorrow's session, okay.
No, to check the continuity of sequences or
Continue. Yeah, in tomorrow's session, okay.
okay.
Okay, so this is the surface. So this z, you can just represent it with f, because z coordinate will represent if there is a surface. Okay, if there is a surface, z coordinate will represent the function value. Okay, so you can replace it like this also if you are getting confused what we have to differentiate. Okay, so this is your function. F is for first f of x square plus y square. So this is your function. So you have to, what you have to do. Okay, what is the tangent hyperplane? So again, all these curves are nice polynomial functions, so no problem will occur. So you can be rest assured. So let's do it. What is the tangent hyperplane equation? Is it z is equals to
f of a
sorry
tilde plus
f of a tilde plus delta f of a tilde
times x tilde minus a tilde.
transpose. Okay, so transpose is another word of saying dot product. Okay,
unit.
so dot product with
minus a tilde.
yeah, x tilde minus a tilde. Okay, your x tilde represents x and y. I hope you are getting x tilde is basically a general point x comma y. So this is your direct equation. So you can find. So point in question was 112.
Sir, here.
So yeah.
Sorry.
Point.
So here gradient vector into unit vector also we can do that, no, sir?
Unit vector. No. Why unit vector? See, try just go back to the lecture and see the tangent hyperplane equation. Okay.
Okay.
So there was there was a derivation where we started from tangent line and then we arrived on this. Okay, that is we removed the variable t. So that's how we come onto this formula. So you can see. Okay, I am not going to repeat the derivation. Okay, so f of 1 1. So sorry, one point was sorry. See, yeah, point in question is 112. Okay, so what you have to do is you have to pick just first two. So this is your point in domain f of 1 1. Okay, 2 is the value of the function at that point. Is it clear? Is it clear? So f of 1 1. Okay, so they have given you a 3-dimensional point that is on the surface. Okay, so 2 is the value of the function at that point. I hope you are, this much is clear, right? So f of 1 1 is 2. You can directly write it. Okay, so for all these functions the values will be 2 f of a. Clear? So you don't need to do it again and again by substituting it. I hope this is clear. Okay, so 2 plus delta f. So for this delta f would be 2x 2y. Clear? 2x 2y, and at 1 1 it would be 2 2, right? 2 2. So 2 2 dot product with x tilde minus a tilde. So x minus a what is a? 1 1. So x minus 1 comma y minus 1. Clear? Now just write it 2 plus 2x minus 1 plus 2 y minus 1. So this will give you 2 plus 2x minus 2 plus 2y minus 2. So 2x plus 2y minus 2, z is equals to. So just check it. 2x plus 2y minus 2. So this will match with this. Okay. Now it is asking you the corresponding subspace. So see, the thing is, this is a plane and it does not pass through origin. Because why it does not pass through origin? Because the coefficient would have been 0. Sorry, this term, constant term, would have been 0 if it had passed through the origin, right? So this is not passing through the origin. So any plane which is not passing through the origin is an affine subspace, right? Of 2 dimension in R3. Yes or no?
Yeah.
Sir.
Yes or no? Yeah. Someone is saying something?
No, sir.
Okay, so this is the plane. Okay, so another way of writing plane is x comma y comma z such that 2x plus 2y minus z is equals to 2. Now I have repeated this quite a few times, right? So what you can do is substitute z, express z in terms of x and y, then express this general element. So x comma y comma z is equals to 2 minus 2x minus 2y, right? 2 minus 2x minus 2y, right? So whatever here is given, suppose there are 2 or 3 equations, just solve them, okay, simultaneously. Solve them simultaneously. Whatever you get, substitute in the general element. Okay. So if suppose if there were 3 equations here, 3 linear equations. So what you will do is you will solve these using the Gaussian elimination method. You will determine which of them is free variable. So you will note them down. Then you will express rest of the variables in terms of those free variables. Okay. Then you will in this general element, you will keep the free variables as it is and express rest of you have expressed the rest of the variables in terms of free variable. You will substitute them here. Okay, so you whatever. Okay, so I hope you are getting this. Is this clear?
Sir,
Yeah.
out of these three, we can take any one of them as a dependent variable.
Yeah. See, the thing is what we are doing here is, since there is only one equation, the rest of the variables will be dependent variables.
Rest will
Okay,
be.
so sorry. I mean, there will be 2 free variables and there will be 1 dependent variable. Okay.
Then
Yeah.
it may the basis vector may basis will be may.
So yeah, we are doing that right now. So now note how many variables are there in this general vector. So 1. So what you will do, substitute, write x and y. So you can see that there are 2 in this. So write x, write y. Then substitute x as 1 while keeping rest of the 0 and ignore the constant for the time being. Okay. So what you have to do, write how many variables are there, x and y. So write them separately, plus. Now substitute x as 1 and y as 0 and ignore any constant. Constant means there is no variable associated with it. So 1, 0 and minus 2. Okay. Then for y you will do y as 1 and x is 0. So you will get 0, 1 and minus 2 plus of. Now you will account for the constant. So just write them down, whatever. If here it was plus 1, then you would write plus 1 here. So 0, 0,
plus 2.
2. Okay. So this part which has variables in front of it, this is a span. Okay. So you know that every span is a subspace, right? Span is basically a subspace. So this is your corresponding subspace. So u plus v. This is the corresponding vector and this is the affine subspace. So what is u? U is span of 1 0 minus 2 and 0 1 minus 2. Did I write it the same thing?
No, sir, that's correct. 1 0 minus 2, 0 1 minus 2.
Yeah, sorry. Yeah, correct. So this is your span. So just see where. Okay. So okay. One more thing. We need not do this. What you can do is just ignore this constant. So when we have found the tangent equation, what you can do is just 2x plus 2y. So whenever there is a plane given, 2x, suppose ax plus by plus cz is equals to k. Suppose 100. Okay. So the corresponding affine subspace, corresponding subspace to this plane would be ax plus by plus cz is equals to 0. Okay. Is this clear? So you can directly write 2x plus 2y minus z is equals to 0. So just note it. Okay, again they have written like this. So see where it matches. So you have to just manipulate it. So see z x plus y is equals to, so this is your plane, right? 2x plus 2y minus z is equals to 0. So z is equals to
First one.
z by 2 is equals to x plus y. Okay, so this is your plane. So this one. Clear? Now you can repeat the, so this will be very easy. This will be very easy. I hope you're getting this. Are you getting this?
Yeah.
So I can skip this, right? Exactly the same types of question. Here what you will do, you will take z as z common. Okay. Remember that z is the variable. Okay. I hope you are getting this. Z is the value of the function. Okay. Do not replace x. So z you will take common from here. So what you will get? Z common. So 5 minus xy upon y minus x. Okay. Is this clear? Okay, there is one right, one point. At one point, the function is not defined only. Okay, let's do this third part. I think there might be some problem in this. So xy plus yz is plus zx is equals to 5. So xy plus yz plus zx is equals to 5. Okay, then you have a z y plus x. Fine, no problem, right? Because yeah, I somehow, okay. So see y, okay, so 5 minus xy upon, so z is equals to 5 minus xy upon x plus y. So at 1 no problem, right? I hope this is clear. Because see, if it was, suppose if it was minus, then it would be y minus x. Then it would be here in denominator it would be y minus x. Then you would have a problem. Then you would have to check whether function is differentiable. And obviously, since they have no giving you no piecewise definition, the function won't be differentiable here because it won't be defined. Are you getting this? Are you getting this?
No, sir, I did not get it.
No. See, I am saying, see, right now the function was nice because there was a plus here. So no problem. You took z common. So you had y plus x. So then you sent y plus x in denominator. So z is equals to 5 minus xy upon x plus y. Now at 0.11, it would be 5 minus 1 upon 2. So there is no, the function is not becoming undefined here, right? But if it was suppose xy plus yz plus zx is equals to 5, they had only given you this. So minus here. So xy, so see difference here, plus minus. Okay, so xy plus z, y minus x is equals to 5. So you will get z is equals to 5 minus xy upon y minus x. Yes or no? So then at 1 the function won't be defined. So you would have some option like the function tangent does not exist here. Okay, so null, something like that. So I hope you are getting this. For tangent, differentiability at a point is equivalent to tangent hyperplane existing at that point, right? Yes or no?
Yeah.
Okay. So I think this much is fine, right? Now you are confident in a maxima minima question as well as tangent hyperplane and tangent line questions. Is it clear? Okay, so one more thing. Whatever I was doing here, so see, okay, I will show you an example. Where is one note? One note. See why this might help you sometimes. I think I discussed this, but I left it in between somewhere. Okay, where did it go? Yeah. So, see, the thing is why that logic was important. That is that. Where did it go? Okay. Okay. Yeah. Here. See. Now, there was one question, activity question, where your derivative was this, that gradient vector. Now you have to equate these two equations to 0 simultaneously. There is an and here, right? Because you're equating it to 0, 0. Okay. So you have to solve these. Now, you could take xy square common from here and y square x square, yx square common from here. Okay. So you have, now you have 3. That is x could be 0, y could be 0, or this could be 0, and this could be 0, this could be 0, or this could be 0, right? So I have written this down: x is equals to 0, y is equals to 0, or this whole is 0, y is equals to 0, x is equals to 0, or so. Okay. So now, how will you even form? Are you getting any hint how you will form? Pairs. How you will evaluate any case? Would it be the case that you might miss any particular point? Tell me. Are you getting this now? What I am saying? Why that is helpful? Because see, now anyone wants to say anything here? You might be thinking that no sir, it is possible. Like, I mean, it is possible if you are very well versed with this. Tell me.
It
Am I
may be
audible?
like to reduce the number of trials to check every situation. It's like that.
Yeah. So the thing is, you might miss some case in some cases. Okay.
That also.
So see how, if you follow this logic, I mean digital logic part. So what you do is substitute p, just assign some variables to these conditions. Okay, just wait 1 minute. There is a lot of noise from my end. Okay, so see, just substitute. So x is equals to 0 is here, x is equals to 0 is, so just substitute them the same way, I mean assign them the same variable, then q, and these two are different, right? So just substitute them r and s. Clear? So now this is one condition. So see, there is an or here, right? You are getting this, right? You can even see it from there. X could be 0, or y could be 0, or this could be 0, right? So you can write it p plus, whenever or is there, plus q plus r, p plus q plus r. Now this equation whole has to be simultaneously satisfied with this. So that's why and, right? Both should be true, right? Both should be equal to 0. Then only you have this equal to 0. Are you getting this? And so we don't write and here. So those are different. So you write dot in place of and. So okay, because see, this is logic, then there is boolean, then there is set theory, so all have different symbols for or and and. So again, now this is q plus p. I am writing this second equation, q plus p plus s. Clear? Now you can, what you can do is you have to simplify this. So pq just distribute it, pq plus pp plus ps, fine, plus q plus QP plus QS, you will get 9 terms. Then RQ plus RP plus RS, fine. Then you know whenever you see two variables PP, so just reduce it to P. Is there any other? Q, there is Q plus PS plus Q plus QP plus QS plus RQ plus RP plus RS. Now see, now what you can do is, see there, if whenever you see some single q, okay, and you see there are some other variables also which has q, okay, which has q in front of it. So and similarly for p, whenever you see some single p, try to collect them. So p times, so I will collect this, I will collect this, and I will collect this, and I will collect this. So p times of, so when I take p common, I will get 1 for this plus q plus then this q, okay, this q, then I will get this p r, right? So I've collected this term, okay, one is left, s term, this term, then qp, this term, q, then one more, so how many terms were there? One, then q, then q, then s plus r. Okay, now I will similarly, I have one q, so 1 plus, okay, 1 plus, what will I get? Q 1 plus, so I, okay, I will cancel these two, these all, okay, so I'm left with r plus s, okay, r plus s. So I think we are done, right? 5 terms here, 3 terms here, okay, one is left. Okay, so yeah, 1 plus rs, there is no p or q right here. So now you have a 1 plus, so one is or, right? One plus is or, right? So if you have a true, so one, always treat 1 as true, I mean 1 is true and 0 is false. So if you have true or something, whatever it is, this is known as absorption law. Okay, so absorption law. So when you have one or with something, so it will be 1 only, right? So p, okay, plus q, similarly here q plus rs. So now you just have these three conditions, that is p is equals to 0, r is equals to 0, and rs. So you have to just solve these two, and you have these, so you have basically 3 cases. Clear? So now you will never miss anything. I hope this is clear. Case 1, case 2, case 3. So you will equate p, what was p? P was x is equals to 0, okay. Now you will find corresponding y and z, okay. Then you will have y is equals to 0, and now you just have to solve these. rs tells you and dot, there is dot here, so you have to just solve these two. I hope this is clear now. Now you will never ever get confused, right? And never ever miss any case.
Sir, okay, PQ clear. What is RS?
RS was this term, right? RS was this condition and S was this condition. So these are basically propositions. Don't sweat it. Okay, so R and S. So you have to solve these two simultaneously. So you can solve these two simultaneously here. So 8 minus 4x square minus 2y square is equal to 0, and 8 minus 2x square minus 4y square is equal to 0. So what you can do is multiply this with 2, subtract it from first equation, you will get y square. Okay, then you can get x value. So you will get basically 4 points, 4 or 2 points, whatever it is. I hope this is clear now. Is it clear? Is it clear?
Yeah.
Yeah. Okay. So I hope the session was helpful. Like,
Sir, I have one question on. Sorry.
Yeah.
Not in this topic. Can I ask?
What? Yeah. Fine.
Yeah.
Yeah. Okay, so it is not related to this, right?
No, sir.
Okay. So first, just wait 1 minute. Okay. So start streaming. Start.